Okay, you guys, next we're going to redo question 8. And let's see, which is better lighting? My lighting changed here. So, okay, we're going to do this one. 49 is our number. So our first step is always to write that number at the top of your factor tree. And then you're going to write the 2 branches of this tree. And this is our factors that we're missing, the multiplication blocks that multiply up to 49. So if you don't remember, you can look at this fact here. 49 is 7 times 7. And so we're going to put 7 times 7. And the only 7 you're going to find on this sheet is 7 here, 1 times 7. And 7 is here, 1 times 7. Anytime a number is divisible only by itself and the number 1, it is a prime number, so we can circle those. So our prime factorization for 49 is 7 times 7. I feel like that's still a little hard to see, so let me switch my lighting. Okay, I think that's a bit easier. Okay, let's do number 9, which is 44. So our first step is to write that number at the top of our factor tree. Put the branches. What times what multiplies up to 44? Now here you have some options. You could do 2 times 22, but you might not have known that fact. You could do 4 times 11. So let's do that one. 4 times 11. Now we're going to build the branches for this 4. We know 4 is a composite number because it's divisible by more than 1 and itself. It's also divisible by 2. 2 times 2 is 4. We go back to our handy list of prime numbers that we memorized. 2, 3, 5, 7, 11, 13. Repeat that after me. 2, 3, 5, 7, 11, 13. Okay, so we're going to circle those 2's because they're both prime numbers. And let's say those again. 2, 3, 5, 7, 11, which is also a prime number. So all of my numbers are circled. My factorization is complete. I write it in order from smallest to largest. 2 times 2 times 11. And remember, we can check our work. 2 times 2 is 4, times 11 is 44. These bottom questions are the same. They're just using this square to be a symbol in your math. So we want to find the missing number. So look, it's given us part of our prime factorization, but something's missing. Now, there's lots of ways we can figure this out, but I recommend let's just start like we're factoring it ourselves. So we draw our number, we put the first branches of our factor tree. Now, we know that they're going to take a 2 out, right? So let's do that. We'll take a 2 out and we'll circle it because we know it's prime. 2 goes into 104 how many times? Well, we probably don't have that fact memorized. And we have not yet done long division with the standard algorithm. But I'm going to remind you because you did it in 4th grade most likely. So we're going to see how many times 5 goes into 104. Not 5. What am I doing? 2 goes into 104. And remember, we checked, can 2 go into 1? No, it can't. So we take the next digit over. Can 2 go into 10? Yes. 2 goes into 10 5 times. That is a 5. 5 times 2 is 10. We subtract, bring down. We are going to go over all of these steps, you guys, when we get to this part. 2 goes into 4 2 times. 2 times 2 is 4. 0 remainder. So we've got 104 is 2 times 52. Now, we know that's not a prime number here, 52, because look at, they've taken other things out of it. So let's branch it off. Let's take this 2 out. And we know we can circle it because it's a prime number. Now we have to figure out how many times 2 goes into 52. Now we can do this long division, or we can skip count and count them 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. But we ran out of fingers and it's hard to lose track. It's easy to lose track. So let's do another long division problem. 52 divided by 2. How many times can 2 go into 5? 2 times. 2 times 2 is 4. I subtract, bring down. 2 goes into 12 6 times. 6 times 2 is 12. There we go. So we've got 26. Oops, don't circle it. 26 is my answer there. 2 times 26 is 52. Now, they've given us this, we have a blank here, so we know there's 2 more branches, and then a 13. We know they're going to take a 13 out. And 13 is a prime number. If we remember our 2, 3, 5, 7, 11, 13, 13 is one of those prime numbers we want to memorize. So we can circle that. So we've got one missing number. So what times 13 is 26? What times 13 is 26? It's not a fact we memorize in our multiplication because we usually stop at 12, but it is 2. So the missing number here, this square represents a 2. Whew, that was a really hard one, you guys. They gave us a big number, and so we're going to do this one that's a little bit easier. Number 11, 55. We write that at the top of our factor tree. 55, we give it some branches. What times what is 55? If you don't remember you can always look at your multiplication chart. You're going to scan for the number 55. Oh, there's a 55, and that's 5 times 11. Oh, that's right. 5 times 11 is 55. Now, what's special about 5 and 11? Well, if we remember our prime numbers, 2, 3, 5, 7, 11. They're both prime numbers. That means that they're both only divisible by 1 and those numbers themselves. So what's missing here? It's a 5. Something times 11, 5 times 11. Last one on this page. We have 77 at the top of our factor tree, and look at, they gave us one of them, 7. 7 times what is 77? 7 times 11. We know that 7 is prime, and it's even included right there. Is 11 prime? Let's see. 2, 3, 5, 7, 11, 13. Sure is. So our missing number here, that square, represents an 11. If you need to pause the page here, you can and finish filling that out. If you're ready to turn it over, you can keep us going. We're on the very last page of our homework, of our independent coursework, and we've got problem solving, and it says to use this table for the exercises. So this is the popular breeds of dogs and then how much they weigh, and it wants to know the prime factorization for these. So we have to get the prime factorization for all of these numbers. I'm going to go ahead and have you pause the video here if you know how to do it, and then you're going to come back and we're going to check our work. So go ahead and pause the video and fill out the prime factorization for each of these numbers. They didn't give you a lot of room on here, so you guys are going to have to just probably find another spot on the page to do it. So like we can start here with 20 and make our tree. 2 branches. I'll do this one with you. We've got 2 times 10. I remember that 2 is a prime number, so I circle it. What times what multiplies to 10? Yep, 2 times 5, and those are both prime numbers. So my prime factorization for 20 is 2 times 2 times 5. So go ahead and pause the video and fill out the rest of that table and then come back and check your work. I'm almost done. You can do your microwave now.
Do you know where the paint stuff is?
I don't.
I just want to feel something.
It was in a box.
I
think it's in the hall closet.
Still don't know my name.
Does anything multiply up to 67? Or is that a prime number?
67 prime.
They're tricking them on day 1 with a crazy big number.
Yeah. Well, I asked Mom where I have dinner and she said there's all of the stuff in the fridge.
No, you asked me that about lunch, Abby, hours
Okay,
ago.
well, I'll still eat.
What did she eat
Where
up?
was the turkey dogs? I told Nathan Byron to have it.
I had no idea. There's still more.
Mom's making pork chops, I think.
Okay, well, I can have some of that too. There's still more turkey dogs in there.
There's two.
Sorry. I meant to.
I know. Is that your special thing?
What? It's mine. I need to get it. Just give me a second. I gotta finish this. Okay, you guys, I have written in the work here the answers to these questions. 81 is 3 times 3 times 3 times 3. 67 is 67. I'll explain that in a second. 25 is 5 times 5. 70 is 2 times 5 times 7. And 50 is 2 times 5 times 5. Let me show you how I got those answers in case you didn't get them. Let's do the prime factorization of 81. Look at my multiplication chart. What times what is 81? Oh yeah, it's 9 times 9. That's my first branch on my factor tree. 9 is not a prime number, so it has more branches, and that's 3 times 3. Those are prime, so I can circle them. And this 9 is also going to break down to 3 times 3. So we got 3 times 3 times 3 times 3. 67, you guys, they totally tried to trick you. If you stared at this multiplication chart, you will not find any 67. You'll find 66. You'll find 63. You won't find 67. And that's because it's actually divisible only by 1 and 67, which makes it a prime number. So the prime factorization of 67 is 67. They tricked you there. It was pretty hard one. We've got this beagle, 25. So we're going to start our factor tree for 25. What times what is 25? It's 5 times 5. Those are both prime numbers, so that's where we can stop. Remember, we memorized that list, which was 2, 3, 5, 7, and 11, 13. And it saves us some time if you memorize those numbers. 67 is eventually on that list. And we didn't memorize that far. You can memorize more prime numbers, but most of the time, these ones will be what you need to know. So 25's prime factorization is 5 times 5. 70 was our next one. What times what is 70? Well, I think of 7 times 10. 7 is a prime number. I know that because of my list of prime numbers. It's only divisible by 1 and itself. What about 10? Nope, we can go 2 times 5. 10 is a composite number because we can break down the multiplication. So 2 times 5, those are both prime. That makes our answer 2 times 5 times 7 for 70. Last one is 50. Let's do 5 times 10. I know that fact. 5 times 10 is 50. 5 is a prime number. 10 is a composite. We just did that one. We can break it down to 2 times 5. So our answer for 50 is 2 times 5 times 5. That is where I want you guys to stop. The rest of the page you do not have to do. That has been plenty of prime factorization for today. We will be working on this more in the future. Keep up the good work.